So yesterday we used the normal CDF function on our calculator to find the area under the curve between two values. So we said if we wanted to figure out what percent of people got an SAT score between 1,000 and 1,200, we could use the normal CDF function to find that. Now we're going to do the other way around, which is the InvNorm function. Okay, I have no idea what it stands for. Probably inverse normal. I'm not sure. But basically, we're going to go the other way, right? Okay, so this one, InvNorm, is the function. So we're going to say, if I know that there's 75% of people under the curve, what are the values on either side of that? Okay, so we're going to look at something like this. I'm going to say, hey, I have this normal curve, and I know that 75% of the people are right here. What is this number? Or we might say, I know that 75% of people are between here and here. What are those numbers? Huh. Didn't erase it on mine, but it erased it on yours. That's fine. Anyway, we're looking for the numbers that would give us maybe the middle 75% of people, or the middle 20% of people, or we're looking for the numbers that would maybe we're only looking for the top 1%. We're saying, what's this top 1% of a curve? It's really sad that you can't see my curve. I don't know why it erased it on yours and not on mine. All right, there you go. So we're looking maybe at the top 1% of earners in a company. And we want to say, well, what number does this have to be so that the area under the curve is the top 1%? Okay, so let's see. Here's an example. We have a seedless watermelon, and they're normally distributed. The mean weight is 6.6 kilograms with a standard deviation of 1 kilogram. So X is our random variable, which basically tells us that we're looking at lots of seedless watermelons, and we're trying to figure out what the anyway, we're finding out z-scores and stuff like that. Don't worry about what we're finding out. We'll each one finds out something different, and it doesn't make sense for me to explain each one of them right now. Okay, so what are we looking for? We're looking for a z-score for a seedless watermelon weighing 7.3 kilograms. Remember, a z-score means this is how many standard deviations away from the mean that this number is. Okay, so we have this normal curve that we can kind of think of. Okay, and then our mean is 6.6. And we're trying to figure out how far away from the mean is 7.3. So remember, we take 7.3, which is our value, we subtract our mean, which is 6.6, and we divide it by our standard deviation, which is 1. So 7.3 minus 6.6 is 0.7. We divide it by 1, it's still 0.7. So this is our z-score. So that means that 7.3 is 0.7 standard deviations above the mean. Okay, what's the probability that a randomly selected watermelon will weigh more than 7.6 kilograms? So again, we've got this distribution, right? And we know that the middle of this distribution is 6.6, and we're trying to find the probability that we're going to pick a watermelon that's more than 7.6 kilograms. So what would that mean? Well, what's the area under the curve right here? How much of our data is under the curve right here? All of this is under 7.6, so we don't care about any of those watermelons. We only care about what percentage of the watermelons are bigger than 7.6. So we're looking for the area under the curve here. So we're going to use the normal CDF function here. Pull up your calculator. We're going to go to second and distribution. And again, we're going to do normal CDF. And we want to figure out our area under the curve from 7.6. And our upper value, remember, we're going to a positive infinity. We're going as big as we possibly can. We want something like a huge, huge number. So I'm just going to leave my huge, huge number in there. Our mu, or our mean, is 6.6, and our standard deviation is 1. We're going to paste that. And it tells us that the area under the curve is about 15.866%. So this area right here is 15.866. See, I cannot even remember from switching from one to the other. 15.8, yeah, okay. I can remember, but then I second guess. All right, 15.866%. So if we randomly select any watermelon off of the shelf, We have a 15.866% chance that we pick one of these watermelons instead of one of these. All right. So this is the new stuff. Just kidding. Not the new stuff. This is yesterday's stuff. What's the probability that a randomly selected watermelon is between 6.4 and 7.2? So again, we're just looking at this curve and we're saying, what's the probability that we're going to pick one from 6.4 to 7.2? Now again, we can't use the empirical rule because this isn't exactly one standard deviation away. So we're just going to use the normal CDF. Norm CDF. Our lower bound in this point is 6.4 and our upper bound is 7.2 because we're going from 6.4 to 7.2. We have the same U and sigma, paste. All right, so we get 30.5%. So remember, this is a decimal that represents a percentage. So we got to move the decimal place. So we have 30.5%. So we have a 30.5% chance that we're going to pick the area under this curve right here. This is 30.5% of the watermelons are in that area, which means if I pick a random watermelon, I'm going to have a 30.5% chance that I'm going to pick one of them in that area. All right, here's our new stuff. What is the 80th percentile for the weight of seedless watermelons? So you have this curve. Remember, the 80th percentile means that we have some number here, and the 80% of all of our data is below that point. So 80% of our data is down here, and we want to figure out what this number is. Okay, so we're going to use our calculator to figure that out. There's these things called z-tables, and I'm going to tell you, in college they made me use the z-tables. I'm like, why did no one teach me that this could be done on Excel and a TI-84? If you don't have a TI-84 at home and you haven't downloaded the free software because, you know, pandemic, then go ahead and just Google how to find this kind of stuff with Excel or with other things. There are ways to find a value given the area under a curve. But we're just going to use the TI-84. Okay, so we're going to go here. We're going to go to second, distribution again, and we're going to go to InvNorm. We're going to push enter. All right, so we're looking for an area. What area are we looking for? We're looking for 0.8, right? 80%. We want to know what values give us an 80% area. We have to give this our mu, or our mean, and our standard deviation, which is 1. And then this asks us the tail. So this is saying, are you looking at 80% here, or are you looking at 80% here, or are you looking at 80% here? Okay, so this would be a right tail, right? So we're saying this would be, I want on the right tail of my data, I want 80%. This would be a left tail. This says on the left tail of my data, I want 80%. And this would be the center, which says in the center, I want 80%. So we're looking at the center, and that would obviously leave 10% on either side. Now, if you have a slightly older calculator, it doesn't often have the left, right, and center. You could possibly try to update your software, and that might help update your operating system. But if that doesn't work, most often the older calculators just give you a left tail. There's no other way to do it. So if you're looking for a right tail, you're going to have to figure out what this would have to be. So if you're looking for like a right tail of 80%, what would be on the left of it? Well, it'd be 20%, right? So instead of putting in a 20%, or instead of putting in an 80%, you'd put in a 20, if that makes sense. But I'm not going to spend a whole video on that because we're already 9 minutes in. Okay, left tail, enter, paste, paste. So we paste that in and we push enter. And this tells us that the number that would give us 80% of a curve to the left would be 7.44. So the 80th percentile for weight of seedless watermelons is 7.44 kilograms.